Hello and welcome to this Manufacturing Systems Technology Module 40. Brief recap of what we did in the last lecture. We talked about the various canned cycles, and there are certain G codes or preparatory codes which are available for representing the canned cycles, including the basic operations like drilling, counter boring, so on and so forth. We also illustrated some of the basic G codes needed for linear interpolation and rapid point-to-point positioning system, which otherwise is executed using full speed of both the motors of both the axes. So today we will be seeing some other commands which are useful. For example, axis motion commands and miscellaneous commands, and some things related to feed and speed. And so discuss in great details about all these different commands, and then probably towards the end of this module, maybe in the next module, we will also do one program, full program, NC part program of a certain situation, a specific situation which has been provided. So let's look into axis motion commands. So obviously these are the set of commands which are used to specify the axes that are required to move during the execution of a given command. So there are two different possibilities here. One is the absolute positioning, and another is the incremental. And I think we had talked about this in quite detailed manner earlier. And so the absolute and the incremental positioning is totally based on whether you're basically reading with reference to the origin, or you are going from one point that you have already reached to the next available point in the array of motion. So during the execution of the given command, it is basically the stepper motors which operate and the axes start to get traversed. Okay. As you have been seeing earlier in almost all the NC programs, such commands are given through the coordinate which is involved. For example, let's say we say capital X for 3, meaning thereby that the X is corresponding to a axis motion command, and it merely represents a certain X coordinate if you're talking about absolute positioning with reference to the origin. So in the next line, if there is a certain other X which is there, it will automatically give you a relationship between how to move between the previous X and the next X. So this is represented in more than 2 lines. The motion is represented in more than 2 lines in such a system. So the letter specifying X followed by a dimensional information is associated with the motion of the axes in question. And the XYZ commands respectively specify the motion of the Cartesian coordinates themselves. And I think I had illustrated in great details about the values ijk earlier, where ijk really are the representations of the offset that is there from a central radius, so that it can give you a basis of the beginning position of an arc, which the circular interpolation can happen in either in a clockwise or a counterclockwise manner. So the I, J and K's are also sort of values which specify the offset relative to the X, Y and Z axes. So some controllers are really designed for the polar system of coordinates, where you'll have a radial and an angular direction, and so for that the subscripts that you use is R and A, indicating radially outward or inward, and then angularly whatever is the direction. Obviously the same methodology has to be followed regarding the positive and the negative directions, as has been discussed earlier in case of clockwise or counterclockwise rotation concerned with the particular axis of motion. The dimensional data associated with the axis commands, of course, comes from, as illustrated earlier, some of the preparatory functions. In this case it is typically G90 or G91, which gives you an essence of absolute or the incremental dimensioning. And we have really maintained again and again that these two are completely different systems of part programming, and one is more convenient for the operator to read and just as a function of the the coordinates that a drawing would have, try to just mention about those coordinates and let the controller do the remaining job of calculation in between. Okay. So the dimensional data associated with the axis command contains mostly real numbers. Real numbers meaning you can have up to the decimal places. Obviously, the decimal places are represented in terms of the two subscript numbers which are associated with that. For example, if I say plus minus x43, it means it's a real number which can go from 0000.0002 to 9999.999. So I think we had at length discussed about this when we were talking about the controller code or the controller specification which is given by the machine manufacturer. So an important point to remember is that the axis commands guide the motion of the point defining the tool position. And for some operations such as, let's say, profile milling, the problem happens because now the periphery of the cutter moves along the surface that has to be machined rather than the tool point. Okay, and the tool point in this case is sort of the center of the cutter. So I would say that in such situations when there is a circular cutter being used and there is a difference between the actual the tool point which is more closer to the the machined workpiece and the radial center of the tool, we use a particular preparatory function which is known as the cutter compensation, which is sometimes given as a part of the controller capability. So if you are able to just map the tooling center and the way that moves, and you have already given the data for the compensation, the cutter compensation value, automatically it would describe the tool point, okay, based on the program. So the actual motion obviously would then be different, quite different than the motion of the tool center, and that's how you can actually program mostly cutter compensation. So it's programmed using the codes G41, G42, and then obviously it is a sort of a modal command which once if programmed would remain in the system. Every time it would get executed unless you cancel it. So the cancellation command for that cutter compensation is the code G40. Okay, so these are the three preparatory codes or G codes which are used to indicate the cutter compensation part in the program, program. So that's all about axis motion commands. Obviously now you are concerned with how the tool moves with respect to the workpiece. Once you have given from where to where it should move, it should also be able to describe at what rate it should move. And so therefore feed and speed commands come into picture. As the name probably suggests, speed and feed commands are mostly used to specify the feed rate and the speed used during the machining operation. And the feed command is specified by the address script F. Okay, you can see mostly in all the controllers specifications the letter F with a plus minus again, and with also with a numerical value like let's say you can define as F plus minus 40. Okay, so again it means that what are the number of digits up to which you can actually program. So it can go from 00000 to 9999, different feed values, and that's what the capability of the controller would then be. So similarly, even speed command is specified in a similar manner, and only thing is the letter S is used instead of F, and the feed rate and the speed used during the machining, they are of critical importance. And that's towards how much time it will take for machining the particular part. So I think we already know about these terms, feed rates or speed. Normally feed rate is specified in terms of units per minute or units per revolution, where units may be described in different systems like the FPS system inches or the metric system millimeters, so on and so forth. So feed rate obviously can be either in terms of per unit time or per unit revolution of the workpiece. It's very handy as per unit revolution when we're talking about a turning center, for example. And just need to mention that the preparatory functions G92 to G98 are generally used to designate how the cutting conditions are to be specified, okay, whether it is a inch per or unit per revolution or unit per minute rate at which the feed has to be specified, so on and so forth. So that's about feed and speed commands. We also have in detail mentioned the identification commands, which are really the address for a given block, the start of a given block. So we generally address this with the number n, and the n word is mostly the most common identifier for an individual block. And although the MCU itself does not use the data contained in the n, but it is actually used as an indexing tool mostly, so that you can see what comes in sequence first and what comes in sequence later. Okay. So normally, I think I've illustrated this earlier, but again I want to reiterate that for convenience of the human users, it is a good practice that you leave gaps in between when you're talking about the particularly representing the n values. For example, you can have one command block to have n05 and following block to have n10. So you're skipping 5 steps in between. And this is normally done in all the programs, because if the controller has the capability of going from, let's say, for example, 1,000 steps, you always try to cover as much possible in terms of the n numbers, so that later on any modification in the code, etc., that may be undertaken can be easily implemented. So if you have gaps between the first line and the second line in terms of the identifier numbers, then those gaps can be filled on later on if you want to modify the code in between somewhere suitably, without really having to write the whole code again. Okay. So this is more from a user's convenience point of view, that these various n numbers are illustrated on the different command lines, and that's how identifications have been done. There are several other identification commands, like let's say this word T here, which represents the individual cutting tool with a number. So obviously, if there is a tool magazine or a turret which contains many tools or tool tips, there is always a tendency of tool selection to happen within the. So the first logical step for the machining to be executed in a proper manner should be the tool selection in that particular case. Okay. So here, for example, T01 would identify the first tool. Similarly, if I'm saying that the tool can go up to 20, T20, so it means that you can go from all the way from 00 to 99, so about 100 tools that you can actually be able to designate. So T20 would be then identifying the capability of that the controller can handle in terms of the number of tools. Okay. So in the same manner, you have described the tool selection process, and the other identification commands are used to identify special sections of the part program, such as loops and macros, okay, that can be executed more than once during the running of the program. So we then come to the last available type of command, which is the miscellaneous command. It's normally used to control a variety of machine functions that are not covered by the other commands done so far, like preparatory commands, access commands, feed speed commands, the identification command, so on and so forth. So here, as the name suggests, the first letter M of the miscellaneous is basically used for executing these commands. I'll just share with you a list of such commands which are available. For example, some commonly used M codes could be how to stop a program. M00, M01 is optional stop, 02 is the end of the program. You can also let the spindle turn clockwise or counterclockwise based on M03 or M04. You can have a spindle off on. You can have a tool change, mist coolant on, flood coolant on, all these different options given by the various miscellaneous commands. So these are really the operations which have not been covered so far in terms of the other functions that have been described earlier. And generally the miscellaneous commands take effect after execution of the other commands in the block, so they are last in the row, and that's how they are also programmed. If you look at a controller specification also, the miscellaneous really comes towards the last of the particular command line. It's usually permissible to produce more than one miscellaneous command in a given block, as long as they don't have any conflicting interest. For example, you can't say coolant off and on together. Okay, so that doesn't create any sound basis. So as long as there are no conflicting natures of these commands, you can have multiple miscellaneous commands in every command block. So that's about it. So that's sort of bringing us to the end of this particular module when we are talking about the various programs. The only other small thing which we need to mention are these sometimes special characters like percentage sign, etc., which are done to just indicate the start of the program or the stop of the program. So generally the percentage sign common to all controllers is used for indicating the first line of the program. And so these special characters are just over and above whatever has been discussed so far in terms of the G commands, the FS, the access motion commands, the identification commands, and the miscellaneous commands. So they are also serving some role, the special characters, in terms of start of program and stop of program. Okay. Particularly when you're talking about ending the program, you sometimes write end of block, the letters EOB, for example, illustrating that the program has stopped and that particular portion. So this gives you a holistic overview of all the modalities associated with the NC program, part program. Now we'll do actually a part program in the next module and try to identify in a very nice and intuitive manner how the machine path can be planned based on the program. Thank you.